Hey, good afternoon, everybody. I'm Andrew Steyer from Booz. I would say thanks for joining me after lunch, but we already got the introduction right. But hopefully you find some of the things that I'm going to talk to you about today compelling enough to maybe take back to your organizations, or at least stay awake for the next 30 minutes and fight the lunch crash. But ultimately, I'll start with defining the problem. As we see it, the current threat intelligence posture that we take in the community, we find to be insufficient against these nation state threats. So these are these complex threat actors that really have unlimited time, money, people, training, and resources to get after us, right? So if we're watching our own organizations, we're already losing. Honestly, that's because they have just immense tooling and time to conduct these attacks, and sitting there and watching, it's already too late. But with that complexity and that sophistication of these groups comes signatures, right? It becomes really important to understand how these individuals operate as a unit, right? The training that goes into it, the tooling that's developed between organizations, and then honestly, the intent behind their attacks, whether that's espionage, that's stealing intellectual property, or sabotage. Honestly, every attack from a complex group has intention behind it, which lends itself to us being able to develop these signatures and develop a good understanding of the TTPs that they employ, right? So with this also comes many different steps prior to an attack being launched, right? If we're sitting there in traditional blue space, we're normally focusing on that last mile into our networks, the attack as it's happening from the C2 into our organization, and our visibility is really limited by that attack as it's happening. But with these organizations, they really focus on mitigating risk and building out a complex environment before these attacks ever take place. And with that becomes multiple opportunities for us to hunt forward and identify metadata artifacts that can illuminate a more complete picture of what an adversary's intent is from the reconnaissance phase all the way down into launching the attack. We are focusing on illuminating those and enriching everything that we can to ultimately cross-correlate any artifact, whether it's traditional CTI like atomic indicators, or just various registration information, certificates, things like that, that we can pull in and give us the most complete view that we can to really focus on where individuals make mistakes, right? As attacks are happening, usually the deployment is very solid. There is nothing to really figure out there, but we do find that people make a lot of mistakes in their configuration, or that they have patterns as they develop code bases to set up their VPSs, to configure their infrastructure and everything along the way. So with those steps, what we're doing is we're not focusing on blue space, but we're going out into what we're calling gray space, right? This is out on the open internet. It's not focusing on what's happening to us as an organization, but it's focusing on what those adversaries are actually doing. Now, as I mentioned before, right, they have intent. There are TTPs. There are things in our toolbox where we all go through the same trainings, right? There are signatures that we can identify and start to characterize those groups based on what they're actually doing. So when I'm talking about gray space, I'm talking about the traditional atomic indicators that everybody's familiar with. And if you're thinking about a traditional blue space approach where we're watching what's happening in our own logs, we're focusing on those MITRE ATT&CK TTPs that are really like privilege escalation, traffic obfuscation, things like that. But we find a lot of value focusing on domain data, DNS records, service banners, and things like that that are all available out on the open internet. So these are things that traditionally an organization may not pay a ton of attention to, because you're going 2 and 3 and 4 and 5 layers deep into that attack chain to ultimately identify everything that you can, and then again, capitalize on those mistakes that actors make. The way to do this, there's no way to do it manually, right? If you're really trying to boil the internet, boil the ocean, if you will, there's too much data. Nobody's going to pay for the right licenses to be able to run every single website that's registered on a given day. You can't run every single IP address that you want for enrichment. But what we're doing is we're taking basically billions of unorganized events. We're taking an AI-focused and ML approach to pull those into our environment to ultimately pre-qualify what looks to be malicious. And then we start making use of the enrichment services and things like that to really expand out our picture. and ultimately boiling that down into insights that our analysts can take from there. The way that we are doing this, as I mentioned, the traditional approach we found to be insufficient. We found that we really needed to build a very robust targeting and data environment for us to handle this solution. So we've automated everything that we can, right? We're talking about MISP as a traditional solution, and OpenCTI for visibility. But what we found is that if you start to take things like our traditional atomics and build it out into, as we're using AWS, you can start to leverage a bunch of different services to automatically enrich things as they hit the environment, to query the APIs of various providers that you end up paying for and integrating into your environment for enrichment, and then doing this on a chronological schedule so that you can identify infrastructure as soon as it's registered, start to pull all of the correlation and information that you can to get ahead of it before the attack is actually launched. So as I mentioned before, we're using OpenCTI as our visualization ultimately at the end of the day. But since we're taking a non-traditional approach using the sticks format, right, for most of our data, we're also pulling in data that doesn't lend itself to characterization and tagging in that way. So what we're doing is taking our traditional atomics, leveraging them in OpenCTI, and we've created labels for our targeting system, right? This is where we can automatically enrich everything on any interval that we program. So this can be daily, weekly, hourly, and monthly. And this really allows us to identify an artifact and then enrich it as soon as it is hitting the system. We're doing this in a variety of ways, using like SQS triggers to pick up those tags from OpenCTI to feed them back into our AWS environment, do all of our enrichment. And then from there, you can leverage services like Athena and Graph Explorer to really generate the relationships that you want, because the best way to get after this stuff is to really do graph-based visualization, because that's really where, as I mentioned before, you start to see the artist's signature come to light. Just like walking through an art gallery, right? You see a Picasso, you know it's a Picasso, even if you're not familiar with every single Picasso painting. These things start to stand out to you as pictures once they're fully enriched and pulled apart. A couple of the things I'm going to speak to you about today are our DGA and fast flux analytics that we've built. But what we're able to do with this environment that we have is really flexibly identify new trends and patterns that we're seeing, and then go build analytics to fetch more data and bring those things in to stay ahead of the curve. So, as I mentioned, it really becomes important to intimately know these apex groups at a human level. I heard a comment made yesterday that cybersecurity comes down to like biology. Humans are in the loop here, and we all have patterns, and we all have things that we know and we've learned along the way. And again, organizations try to standardize their approach for how they take things. So some of the things that we found to be particularly interesting for our gray space hunt are your traditional atomics, but also fusing that with things like dark web and social media monitoring. But really the most important thing here is the global net flow data. When you start to pull this in, you do all your enrichment on your traditional atomics, but really you start to expand that all the way down into the actors as they're provisioning their infrastructure, all the way down to the operator on the keyboard at times, right? So then you can flexibly watch them pivot as they purchase new VPSs for $250, and then reconstruct an attack for a different scenario. But through our entire engine, what we're able to do is take something as simple as a spear phishing email, which you see here at the top of this chain, and through the enrichment of all these different data points, ultimately expand it out all the way down to an operator on a keyboard, as I mentioned before, and then you can start to follow that chain before they're able to launch further attacks. I forgot to mention here some of these services that we find particularly interesting. I mentioned the global net flow before. But things like silent pushes, PDNS, reverse lookups, and things like that. This is where you can take you'll see it in a minute actually. But this is where you can start to enrich even further those atomics that you're seeing. And instead of just worrying about blacklisting IPs and domains as actors pivot, you're really able to figure out how you're able to deobfuscate their techniques. So right here, I'm going to give you a preview of kind of our DGA model that we have running. So every single day, as I mentioned, this becomes a problem of complexity and scale. You can't get after everything that's on the internet, but we're really attempting to do that in an efficient way. So what we're doing is we're taking all 250,000 domains that are registered on the internet on a daily basis, thanks to one of the silent push reports we get, right? We're pulling that in. And then what we're doing is we're feeding it through our DGA neural network that we have. And what that's doing is that's giving us a predictability that these newly registered domains are actually a part of a DGA. This is really important to us because we're seeing that actors will go register infrastructure, conduct their recon for days and weeks before they actually launch an attack. So as I mentioned before, we feed that into our environment. We're usually resulting in domains that have an F1 score of over 90. And we're taking that subset of data. So of 250,000 domains that are registered on a daily basis, we're usually enriching only about 200 or 300 of them. And what that allows us to do is we start to see the actual chains of what's taking place with this. We can see actors as they're actually provisioning this infrastructure. We can see the configuration. And then ultimately, once you have visibility of what they're doing on their own keyboard, you can start to see how they shift from their recon infrastructure into their attack infrastructure and go from there. So this is where the NetFlow data becomes wildly important as well. So it's a matter of taking those TTPs and really figuring out what data you need to go collect to give you that insight into identifying those attacks. And again, as I mentioned before, the more unique data sets that you pull in that are non-traditional CTI data, you need to be able to normalize that and shape it how you want. And that's where we really, in our environment, start to use glue transformations within AWS to start normalizing those things so that we can actually visualize it in Graph Explorer. And from there, we take these clusters and we can feed them back into our OpenCTI environment and our MISP environment to really generate the connections that we're looking for. Separately, from there, as I mentioned, once you can start identifying these DGAs and get ahead of them, you can start to pick up on the commonalities between the registrations. Some of the things that we key in on, right, are listed here on the screen. You can pick out the unique aspects of the architecture, right, and then go generate further analytics to feed your environment from there. So that's where you go out and start conducting your API calls with the tools and services that you're paying for to generate more data into your environment to ultimately train your AI further to be able to hunt forward. So this is one piece of malware that we actually tested just a couple weeks ago before we walked in here, based on an analytic we built from the first DGA output that you saw, and through our tracking and following of it, we're able to tear it apart, generated an analytic on it, and from there we were able to see that just one piece of malware ultimately yielded 4 different IPs and 187 domains within a week, right? These DGAs are impossible to stay ahead of, traditionally speaking, right? Some of them can generate 1,000 domains on a single day. But we found that by doing this in a graph-based environment, it really helps these things come to light. And I actually spoke incredibly fast, so I apologize for that. Hey, lunchtime treat, but thank you guys. Any questions?
So we have time for a couple of questions.
A lot of questions. Anytime. Go ahead.
Sure thing. Could you go back to the slide with the infrastructure at scale and maybe spend more time on that?
Yeah, for sure. Any particular questions on it, or just what we're doing here?
No, just how to replicate this when you're not $1 million company.
Yeah, so I think the thing that you would really want to take into account here is instead of using like we're leveraging AWS for a lot of these services, so we're making use of Lambdas for a lot of the API calls that we're making. So instead of just having a bunch of Jupyter notebooks out there where you're writing Python and conducting separate queries, what we're doing is we're picking up these artifacts that we have in our environment, your traditional atomics, right? And then when I say you use your imagination to figure out what data would be available that's associated with each of them, I'm thinking like a domain, right? There's 36 different metadata artifacts that you can pull out just from a single domain registration. Those traditionally don't matter when you're talking about writing detections or actually looking for things within your network, but they are very important when you start doing cross correlation on them to identify where actors actually make mistakes. So what we're doing here, I guess, is what you're seeing is this target deck. That's where we're actually picking up those atomics from our OpenCTI and staging everything for our follow-on enrichment. The query engine is where we've built out lambdas to make use of all of our different providers' API calls that we want to make, and we're strategically taking the artifacts that we know can be enriched by each of those API calls and pulling them back in. Separately, when I talk about you'll see here you have synchronous data processing and asynchronous data processing. We've built two different engines to support this because some API calls you make, right, you get instant returns on your information, but other ones are streaming and they're running along the way. We found that your environment can fail and you'll get false reports and false completions on enrichments as you're handling thousands of IPs or thousands of domains on a daily basis. So we're further breaking that up into services like from Cumry, where we're getting long net flow data. Those queries can take hours at a time, right? We don't want a quick fail, yes or no. So we have that as a synchronous processing. We're pulling that all back in from there. And then other times, right, you just get data at rest immediately, and we just pull it back in for our services. But ultimately, what we're doing, and the reason we have this separate enclave, is we're also using this persistent storage to then train and tune our ML and AI on top of it, and really working to then federate analytics off of there. So our ultimate goal is to write detections on this traffic and get ahead of attacks before they can actually launch them by looking for like open directories or pulling down malware and interacting with infrastructure ourselves as it's being configured to ultimately write detections. But we also take everything that we're learning of those TTPs and we're working to create federated analytics that we can run within an environment based on what we have in our holdings. So this is this is making use of data at rest, right? But that's really ultimately with the goal to then generate federated analytics going forward. Is that helpful?
Thanks. I have two questions actually. One is like the ML models for DGA and fastplex discovery. That's there's lots of literature on that.
Yep.
But what I found so far, maybe I didn't find the right ones. The false positive rates and etc. is not that great.
Right.
So, but it's still lots of data. So like combine that with lots of data,
Yep.
you got a problem, right? So
That's
how do
right.
you deal with that?
So the false positives aren't particularly worrisome to us because we're not working to generate huge block lists based on what's ultimately illuminated by the ML output. We're using that as our first filter before we actually process everything through our enrichment engines. And that's how you do this strategically in a cost-effective manner, right? So you talk about false positives. We agree 100%, but that's where we're taking our scoring from that output and then ultimately pulling the thread on that further for interrogation. So we're not just stopping at that malicious score that we have. We're then saying, hey, this looks weird. Let's pull the thread on it and see what we can find from getting up further to an actor level. We're not focusing on our organization ourselves. We're paying attention to what actors are actually doing, right? And that's where we then start to illuminate a greater landscape of, the threat posture.
Okay. The second question is related. Could you go back, please, again to where you were? Yes. For the OpenCTI MISP and the ingestion into OpenCTI, I've been struggling a bit with that. Yeah. Okay. I see the same reaction. Yeah. So yeah, anything that you can share there in this direction would be really welcome.
So most of this was born from our frustrations with that as well, right? As we're trying to pull in non-standard data sets, right? Things that aren't in the traditional labels that OpenCTI will handle. Honestly, because the Enterprise Edition even says, you have the ability to create your own sticks formatting, but that just doesn't seem to be completely true. So as we're pulling in things that don't lend themselves to that, that's where we're really leveraging our AWS environment and Athena itself, right? Because then we can start to say, hey, we've created all of these different labels for artifacts that we care about. Let's strategically generate queries that we can then turn into graph-based analytics and feed back into there. So we're using a complementary approach to this, or we're taking a complementary approach anyway, between our two different environments. So OpenCTI is kind of the ground truth of where we're seeing everything kind of published, but a lot of our flexibility in how we're creating analytics and generating insights from data is taking place just from how we're transforming and normalizing everything within glue jobs in AWS, right? To ultimately get us down to what we care about. And then again, pushing what we can that's supported by OpenCTI back into there.
Thanks. Yeah.
Yep.
Have you had any use cases where you're feeding into the model infrastructure that is not stood up by the threat actor, but they're abusing legitimate infrastructure? And if you have run into that, what selectors or data that is used as part of the model has been the most reliable in helping you identify threat actor infrastructure where they're abusing or compromising legitimate infrastructure for things like hosting malware or C2?
Yeah, so our DGA model isn't super great for that, but what we have created is another one called villainous domains, and that's more of an actual AI engine where we're taking artifacts where we're training from our OpenCTI environment, where we've curated known attacks and things that we're seeing, and fusing that with actual malware and intent and different data points from there, and using that to really resolve and paint a more complete picture. So I'm not really like peeking under the hood at that one, but to your point, yeah, that is a very real approach that actors take on a very regular basis. And that's where taking those TTPs from MITRE ATT&CK and really turning that into data that we can start to generate graph-based visualization on helps illuminate some of that. So I'm glad we got all these questions. It makes my short time much better.
How do you manage blind spots of some of those data feeds that you've got, to acknowledging not every system is perfect?
I'm sorry, I can't.
Sorry, how do you sort of manage some of the blind spots that you might get with some of those data sources? So where
Yeah.
you're applying sort of the ML analytics over it, but
Yeah.
you may not have sort of a complete picture. Is there sort of something built into that model that helps you with that or understand it better?
Yeah, blind spots are always going to be a thing. That's where really knowing that we have them and focusing on the artifacts that we do have is the key there. So by expanding our aperture on what we're considering a metadata point that we're going to process outside of what a lot of these providers will service on their own, but you can even see differences in the feeds that you get from two providers, right? By fusing that all together in one environment, that's where we're really getting a more complete picture, and it's cutting down on a lot of the blind spots. But I guess the nice thing is you don't need to be able to see the entire chain all the way down to develop effective detections or to really protect your infrastructure, right? As an actor, really, if they're really good at obfuscation and working their way into their infrastructure, you are going to have blind spots. But if you can ultimately be sitting at a point where you can identify their VPN that they're coming through on a regular basis, right? You can watch what they are doing and start to fill in the gaps from there. You can start characterizing what the activity might actually be, whether it's recon or it's actually launching the attack, right? And then understanding like, hey, the intent of this group is to go after this type of organization. We see two different chains that aren't connected in any certain way, both resolving to the same victim or potential victim. That's where you're like the timing and sequencing and origin, whether it's, JARM fingerprinting for the actual locations and things like that they're coming from. You can do all sorts of timing delays and things like that to really say, these two disparate data points and chains are actually kind of connected together. All right, thanks. Oh no, we got a big question coming.
One more. Sorry, if you could just go in a little bit about the fast flux, because obviously we are also pretty into trying to fingerprint with fast flux information, and so we make specific attributes about IP diversity and AS diversity to get the automation fingerprint of the threat actor from their fast flux pattern.
Right.
So what are you doing with that information, or?
So we're actually taking a lot of your information that you're generating on those adversaries and pulling it into our environment. And as I mentioned, the same TTPs that you're ultimately using to identify some of those, we're more consumers of that a lot of times, right? We're taking the feeds that companies like Silent Push are generating because we know that they're very reputable, and pulling it into the environment to really illuminate what's actually taking place and then building on it from there. So a lot of times it's the seed for us coming into that. And we're using that more for our analytics. It's not feeding our ML, right? We're taking your feeds and things like that straight into our environment as ground truth. And as we can expand on those and do our enrichment and correlation, we're then feeding that into our ML to actually just train against it as, you know, to increase our scoring. So,
Thanks. And then will you share back your algorithm for the DGAs?
with you, yes.
Well, since there are no more questions, let's thank again our
Thank you.
speaker.